Number 12 and 13 are special cases. In number 12, your equation y equals negative 3 has no x in there at all, and in number 13, x equals 6 has no y values. These are the trickiest types. If you notice in number 12, it just says that y is negative 3. It doesn't matter what value of x you pick then. You can pick any value of x you want. You can pick 0, you can pick 1 and negative 1, you can pick 2 and negative 2. You can pick 6 million and negative 6 million. It does not matter what values you pick, because according to your function rule, whatever your value of x is, y is always negative 3. No matter what, y is negative 3. Vice versa. Here, it's telling you that you can only pick x equals 6. So you're always picking x equals 6. The tricky part here is what's y then? Well, it's a similar concept to number 12. You're picking positive 6 for x here because that's what they told you, that's the only thing you can pick. Then y can be anything. If you have x is 6, y could be negative 3. Y could be 0. Y could be positive 8. It doesn't matter. X is 6. That's all that matters. It doesn't matter what y is. Here, y is negative 3. That's all that matters. It doesn't matter what x is. So if you just plotted a few of these, negative 4, negative 3, 0, negative 3, and 2, negative 3, you would see that in this function rule, y equals negative 3, you get a horizontal line. In this case, it has to cross the y-axis at negative 3. If you plotted a few of these points here, 6, negative 3, 6, 0, or 6, 8, you get a vertical line. There's a very big difference between a horizontal line and a vertical line. Not just the way they look, but in what the function rule looks like. Anytime your function rule has a y but no x, you're going to have a horizontal line. A horizontal line has a slope of 0 because your y change is 0. A vertical line has a slope that is undefined because your x change is 0. So in this case you would have a y change over 0, can't have 0 in the denominator. Here you would have 0 over a change in x. That's 0. The last notes of the day. These are similar to the problems we looked at yesterday with missing ordered pairs. And we're just looking at them in a different way. We're looking at them as a table. So instead of giving you the ordered pairs, I'm already putting them in the table. That would be negative 1, 7, and 2, y. You need, in this case, these ordered pairs to equal 2/3. So 2/3 is going to equal, we don't know this, your change in y over, we know this, to get from negative 1 to 2, it's positive 3, so over 3. When you cross multiply here, you find that your change in y has to be 2. 7 plus 2 means you'd fill this table in with a 9. This one's different because now I didn't put the table set up the way that we talked about yesterday, with the completed ordered pair on top. You can do this one of two ways. You can rewrite the table off to the side with negative 1, 7 on top and x, 4 on the bottom. Or you can try to figure it out this way. I would recommend doing it this way with the table. It's much easier than trying to work backwards here. So again, you have a rate of change of 2/3. This time, you know your change in y is going from 7 to 4, that's a -3. That goes in your numerator. You don't know your change in x, that's your denominator. So when we cross multiply, 2 times your change in x equals -9. So your change in x equals -4.5. So put that in for your change in x here. Means you start at -1, you go down another 4.5, and you wind up at -5.5. That's what goes in your table, -5.5. In this case, it's okay to get a decimal in there. It's when you're graphing that I don't want a decimal in there. Go ahead and press pause. Then try these two problems. Unpause to check your work. In the first one, I made my 5 negative. Anytime you have a negative in front, that means either your numerator is negative or your denominator is negative, not both. So in this case, I made the numerator negative. I would always make the numerator negative just to be consistent, but it's not wrong if you make the denominator negative instead, but just not both. Cross multiply, and we find that our change in x is -4. So if this was a -4, it means I start at -5, go 4 more negative, and we wind up at -9. And that would be our answer here. The second one, remember, it's probably going to be helpful if you rewrite your table with the 7 -6 on top and the 3 with the blank on the bottom, or the 3 and the y. If you have not done that, go ahead and press pause and redo this problem. So this gives me a change in y of a +5. So if I start at -6 and I go +5, I wind up at -1, and that's how we would fill our table in here.